Any other housekeeping chores? All right, I failed to turn the recorder on. So once again, welcome to D period Algebra 2, and it's Monday, May 4th. We just went over the announcements on missing assignments, putting names on quizzes and problem sets, and the status of the 6-4 quiz that everyone took last Wednesday. Mr. Melendez, I did not receive a quiz from you, okay? And Mr. Carmen, you know that you've I think, already rectified your issue. All right, any questions?
I don't know why anything's not like sending. Did you get my email of all the missing stuff I had? I sent it to like from my Gmail account. Everything.
When did you do that?
A while ago. Like Friday, I think.
I think if you looking at your Blackbaud grade, I'll do a research on it, but make sure you're using my appropriate email address.
Is it jgaffney@Benedictine
collegeprep.org. collegeprep.org. Make sure it's spelled correctly, okay?
Okay.
If you've got it there where you sent it and you can just send it, I would resend it because I'm making a note here also to do some research on yours. What is it a Gmail address you're sending it from?
Yes.
And tell me what it is.
Logan Melendez4@gmail.com.
Okay, I'll do some research from my end to see if I can troubleshoot.
I'll resend it.
That's the best thing. That might be the
yes, sir.
Okay.
Okay.
All right. Any other announcements? Okay. All right. So we're moving on to the very next section, which is 6.5, which is operations with radical expressions. Okay, which is we're going to take what we did in the previous two sections, and we're going to elevate the complexity even a little bit more. As much as I hate to say it, it does get a little more challenging, a little more difficult. And the other unique thing on this one, it kind of goes back. Remember when we talked back in chapter 5 on complex conjugates, and that's where you had a little bit of a taste of it with radicals in the denominator, which you have to simplify. You want to create an answer with no radicals, okay, in the denominator, and we do that by complex conjugates, which means we just change the sign of the radical, and when you multiply them times each other and do like a FOIL, they zero each other out. All right, I know that sounds somewhat complex, but when you see it, I think it'll look familiar. So let me see if I can share my screen. All right. I will, as soon as class is over, I'll load this up. I'm helping out with Ms. Dalma's calculus class, so I had that beforehand, and I didn't get it, I did not get this loaded beforehand. So if you got loose leaf paper handy, you may want to just jot some notes down on that, all right? So we're going to do 6.5 problem set 1. It's only got about 6 problems on it, but it is.
Are we turning this in, or this just for notes for this class? Are we just going to take notes on it?
Let's just do this for practice and not for turn-in. Let's get the practice out of the way, and then I'll score one. Okay?
All right, yes, sir.
All right, so here we go. Holler if you got any questions. So I'm just going to some of this is refresher, but it's stuff we haven't done for 6 to 12 weeks, all right? So that n is greater than 1. All that's saying is the roots that we're taking, be it square root, cube roots, third roots, fourth roots, whatever, is always going to be greater than 1, all right? So 2, 3, 4, 5, 6, 7, 8, all right? So that's what that is saying. Let me erase my scribble scrabble. Okay. And it says if n is even and a and b are both non-negative, which I don't know why it's kind of like a double negative. which means A and B are both positive. So let's just do that. That's kind of confusing wording. Then we can rewrite this. Let's see, I'm trying to think. Let's do this. Let's do this. So let's just say this is 12 under the radical, and it's a square root, so I'm not going to write n. All right, we can rewrite this as, should write bigger, it's hard to do. I can rewrite that 12, a multiplier of 12 is 4 times 3, right? Why did I pick 4 times 3 as opposed to 6 times 2? Because 4 is a perfect square, right? Which then gives us the option of simplifying this. We've done this before, and this is very simple, is that square root of 4 is 2, and then the 3 just stays under the radical. It's clearly going to say when to simplify and then when to use your calculator to get a very precise answer. All right, which you did some of on the last quiz. Let's see. And if n is odd, meaning third root, fifth root, seventh root, whatever, we can kind of do the same thing. Let's see. I'm trying to think. Let's see. Yeah, let's do this. Let's do cube root of 27. No, let's do cube root of 63. Let's do that. Okay. All right. We can rewrite that as cube root of 27. Sorry for the nasty handwriting. Times cube root of 9, right? Oops, cube root of 3. Sorry about that. All right. And the cube root of 27, follow the yellow brick road, follow the arrows, is 3, right? 3 times 3 is 9, 3 times 9 is 27. So that can come out from under the radical as 3. And then we just leave, I can't simplify the cube root of 3. So that's what that second rule is saying, our property. Questions on that? Does that make sense? I mean, we've done bits and pieces of this, so I'm just trying to kind of clarify and relate it to stuff you know, that we've done in the past. Pretty good. All right. Assuming no news is good news, or you're all sleeping. All right. What the heck is radicand? Anybody know what that means? What's the radicand? All right, let's talk about what the radicand is. Let's see here. Let's do this. I'm trying to think. Yeah, well, let's keep it simple. We're doing the square root of 8. All right. The radicand is that value under the radical. The radicand is the value under the radical. All right. So if you see that word again, or you see it on a standardized test, radicand is the value under the radical. All right. So it says factor the radicand into as many squares as possible. All right. So we can write this in a number of ways, depending on how your left brain, right brain, and how your brain thinks. And I'm definitely not an expert on that. One way to rewrite this is 2 squared times 2. This is radical. Or we could write this as 4 times 2. And we know 4 is a perfect square, right? And this, I'm just applying this property, all right? So then we can simplify this square root of 8 as 2 with 2 still under the radical, 2 radical 2. And that's what number 1 says. Does that make sense? Questions? You just look at the top of my head. Sorry about that. I'm watching what I'm doing and not what I look like. You don't see me anyway. Okay. Good so far? All right. So, all right. Hearing no complaints. Let's do this next one. Let me come up with a good one. What this is saying is use the product property. What's product? You know what product is, right? Use the product property to isolate perfect squares. So I don't know what, 84, doesn't ring a bell, my little 3x5 cheat sheet of all those perfect squares. So you always have this to fall back on, all right? If that last number under the last number of your radicand, a new term you use is even, I'm going to start factoring out 2's. If it's odd, I'm going to start factoring out 3's. So if I factor out 2, I get 2 times 42. Everybody agree? And then I can factor out 2 out of that, and I get 2 times 21. All right? And then 21 is 7 times 3. So it says to isolate perfect squares. So here's perfect squares. I was hoping it's going farther. I just picked that number out of my head. So that can come out from under the radical as 2, all right, with 21 still under the radical, all right? Just like, let's see here. Let's say we are doing, I'm trying to think here. I think this will work. Hopefully this won't backfire on me. Let's say we're taking, you've got 63 under the radical, or 63 is your radicand. Well, that's the same as 3 times 21, right? I think it's going to backfire on me. And out of the 21, I can go 3 times 7. All right, I'm going to have to simplify things here. Let's not do cube root, let's do square root, all right? So I got 3 squared, or 3 times 3, or 9 times 7 there. So I can simplify the square root of 63 as 3 radical 3 radical 7. Pardon my 7 there. Does that make sense? I know my handwriting is as bad as some of your guys, but that's what that's saying, all right? Start pulling perfect squares out. And if you don't know, like I said, start, if it's an even number, start factoring out as many 2's as you can. If it's an odd number, start factoring as many 3's as you can. If it ends in 0 or 5, the number under the radical, or your radicand ends in 0 or 5, I'd start factoring out 5's. Okay? To simplify each radical. All right. Questions, confusion, anything I can clear up? Give me a second here, I'm going to scroll up. Is this sounding familiar? Or does it kind of sound like Greek to you? Anybody? Make sense? Okay. Now, this is similar to some of the stuff we just did. If I've got, and actually there's one of these on your quiz. Let's put a real life number to work on. Let's say I've got, this might have been on your quiz. If I've got 25, under the radical 25 over 36, okay? If it helps you to simplify, it is the same thing as the square root of 25. I'm not going to write 2 or square root in the radical over square root of 36. Does that make sense? So if it makes more sense to write it that way, these are definitely equivalent. The square root of 25, we know is 5. And we know the square root of 36 is 6. So there's my simplified answer of that. Make sense? Everybody awake? All right. Okay, so let's look at this example. Let me scroll up just a bit because it's pretty good. All right. All right. So we're doing cube roots. Okay. So pay attention to that. All right. Let's do the easy part first. I'm going to break it down into chunks. All right. All right. I'm going to work from left to right. It doesn't matter. And I know I'm kind of going contrary to I'm actually going to work right to left. It doesn't matter, but I'm trying to do the easy part first and the hard part last. That way we kind of go our way into the complexity. All right. If I look at b to the 7th, all right? Remember it said something about break it up into many squares or whatever the root is that you're doing. B to the 7th, all right? We're doing cube roots here. Remember, when we're multiplying like bases, we add the radicals. So b to the 7th could be rewritten, and you can rewrite this mentally as mental math because we're just dealing with very small exponents, as b cubed times b cubed times b to the 1st, right? So, so this would come out from another radical as b squared, okay? And I'd still have a b under the radical. Does that make sense before I move on? That's one way to approach or think about it. Another way to approach it is 3 goes into 7 2 times with 1 left over. 3, the root goes into the exponent 2 times with 1 left over, right? So there's the 2 and there's the 1 left over. So that's, depending on how your kind of mental mathematical mind works, that's another way to look at it, all right? So now let's look at a to the 5th, all right? A to the 5th, I'm going to come down here. Again, we're taking cube roots, is the same as a cubed times a squared. Agree? All right. So the a cubed comes out from under the radical as just a, right? And I'm going to leave an a squared under the radical because I got a times a, but I really need an a times a times a to come out from under the radical. All right, so we took care of the b, we took care of the a, and now we got a negative 16. Like, ooh, can I do that with a negative 16? Well, yes, I can because I got an odd root. So the negative is going to come out just as written. Now let's take a look at the 16, okay? All right, so it says, remember, as many perfect squares out of here as you can. So 16 is the same as 2 times 8, right? So one way to look at it, if those bells and buzzers go off, I know that 8 is 2 cubed. So I'd have 2 left over. If I didn't recognize that, I could go, well, that's 2 times 4. And 4 is 2 times 2, right? All right, so here, look at here. So I've got a messy handwriting, but I've got, how many 2s I got? I've got a 2s right there, 3 2s right there. So those 3 2s to the 3rd power can come out as a cube root, come out as 2, right? And what do I have left over? Let's see, 2 times 4. And that's 2 times. Actually, I stole this 2 off the square. It's really this 2. Sorry for the messy writing. And I've got 1 2 left over. So I've got 1 2 that's going to, let me rewrite my radical. So I've got a 2 still left under the radical. So these take some kind of tedious thought and tedious work, and you just have to kind of chunk your way through it. All right? Does that make sense? I'm sorry for the messy writing. You guys are quiet. Everybody sleeping or watching reruns of I Love Lucy? All right.
Yes, sir. Reruns, sir.
Reruns. Okay. So that
Rerun.
now let's see how we're doing on time. All right. I'm just gonna mark this one up. Okay. So let's look at number 2. All right. So all they did is they broke the numerator and denominator and put each under the radical. All right. I'm not gonna write and make a messy work of all this. All right. So they they then broke up that 8x cubed is the same as 2x times 2x times 2x, right? That's that 2x squared. So that can come out from under the radical as 2x. I'm not going to get into absolute values because it's not a complexity I'm going to touch. So right now, we'll address that in pre-cal next year, right? So that comes out as 2x, and it leaves one 2x, this one here, still under the radical. There it is. There it is. And it's going to change here in a minute. So that takes care of the numerator. Now in the denominator, we've got 45 times y to the 5th. And we know that 45 is 9 times 5. We like 9 because the square root of 9 is 3, right? So we've got 3y squared. They kind of tricked you up a little bit here. We got 3y squared and then all of that to the second power. So that is going to come out from under the radical as 3y squared, leaving 5y under the radical. Now, this is a little tricky and a little complex. Use this as a good example, all right? Now to simplify, they do not want any radicals as the denominator down below here, which you've got. So how do we fix that? All right, remember what I do to one side of the equation, I can do to the other as long as I do it exactly the same. So we're going to multiply the numerator and the denominator both by this, what's under the radical here as the denominator. So we multiply everything by 5y. And remember, let's just say, if I've got 7x, the square root of 7x, and I multiply it times the square root of 7x, I got 7x squared, right? Which then can be simplified as 7x. So that's why we're multiplying it by you're multiplying it by itself. And when I say by itself, I'm speaking in terms of the denominator, all right? So what they did is they multiplied the numerator and denominator by 5y. And so now under the radical becomes 10xy, and 5y times 5y is 5, here using my 7x as an example, the radical of 5y times, or the square root of 5y times the square root of 5y equals 5y. And at 5y times the 3y squared now equals 15y cubed. And I know that's a mouthful, and I know that's a little like, this doesn't make sense, but that is an application of these various radical properties. Okay, so I'm going to walk you through a couple. I think there's only what? There's only 6 problems on this, so it's not a brain buster. I'm going to walk you through, let's see here, let me take a look, which would give you the most bang for your buck, and then I'm going to have you do the rest. Let's see here, we will do, let's do 1. Yeah, we're going to do 1, 3, 5, and you're going to do 2, 4, 6. How about that? 1, 3, 5, and you do 2, 4, 6. That's not a whole lot to ask. All right. Any questions before I get into an explanation? And you may just want to do this on loose leaf paper. You won't even have to print this thing out, although the examples are pretty darn good. All right. So we got 5 times 54. And again, we're simplifying, we're not solving. So 54. 54. All right. There's a couple of ways you can look at this. We're going to use the traditional method. It says get as many perfect squares out of there that you can. So it ends in an even number. So I'm going to factor a 2 out of that 54. So the 54 is the same as 2 times 27, right? Now the bells and buzzers go off. Like, well, I got 27. I can't factor a 2 out of 27. But I've got an odd number there. I can factor a 3 out of 27, right? Which is 9, right? Okay, so now the bells and buzzers are hopefully going off in your head, and I know 9's a perfect square, right? And another way I could have looked at this, and I was going to go that way, but I decided to try this way. And either way it works. 54 is the same as 9 times 6. Well, that 9 we like, because that's in that little 3x5 perfect square sheet that you have in your notebook there somewhere. So that 9 comes out from under the radical as what? As a 3. right? So if that comes out from under the radical is 3, 3 times 5 is 15, all right? And we still have 6 under the radical. I can't simplify any further. So that would be the answer that you would hopefully get to, 15 radical 6. Does that make sense? Remember, we're simplifying, we're not solving. Are we good? Now, pay attention.
Yes, sir.
Pay attention to this. That's the fourth root, okay? So I'm not going to do it. Factor out as many 2's as you can do. 2 times 16, then 2 times 8, and then 2 times 4. So I know there's 4 2's in there. Somehow you can get out of there. 8 to the 9th is the same as 8 to the 4th times 8 to the 4th times a. So there's 2 8 to the 4th squared comes out as 8 to the 4th. When it comes out front of that radical is 8 to the 4th, and apply the same thought process to the b to the 20th. Okay? I'm not going to do that one. I want you to do the evens. All right. Clear. All right. So let's look at 3. I'm doing the odds. You're going to do the evens because I'm the odd guy. All right. So I'm going to do the easy. I'm going to work backwards again. No, that's not. 75. Okay. What strikes me is 75 is divisible by 25, right? So that's the same as 3 times 25, right? I love 25 because that's a perfect square, all right? So that comes out from the radical as 5. And I still got 3 under the radical, right? To get back to 75, if I square 25, bring it back under the radical and multiply it times 3, I'm at 75. Okay, x to the 4th is the same. Again, we're doing square roots because there's no value here, so it's always a square root. All right, so it's the same as x squared times x squared. I love that. Or another way you could rewrite this is x squared squared, right? So that's, rats. Let's see here. Let me do my eraser. All right. All right, so now I've got, come on, in. So there's my 5 that I erased, right? The x to the 4th comes out from one of the radicals, x squared, right? Now I've got y to the 7th. So I'm not going to write it down just because my writing is so messy. Is the same as y to the 3rd times y to the 3rd times y, right? So that y to the 7th is going to come out from under the radical as y to the 3rd, right? And let's see, what else do I have left? I've got 1y left, remember, because it's y to the 3rd times y to the 3rd. All right, so there, this is the answer that you would hopefully reach. Questions on that? All right, last one. All right, give me a second, scroll up. All right. Okay. Now, I think this one would be wise to rewrite as separate things. A to the 6th over b to the 3rd. And we're taking square roots because there's nothing there. Over 98. And look at them, kind of compartmentalize and look at them somewhat independently and separately. Okay? So a to the 6th is the same as a cubed times, or a to the 3rd times a to the 3rd, right? So I've got, or you can look at it as a 3rd squared. So that a to the 6th can all come out front of the radical as a cubed, right? And I'm done with the a to the 6th. The b cubed is b squared times b, right? B squared times b. So the square root of b squared is b, and I still have a b under the radical. So that wasn't too bad. There's the numerator. Now, 98. All right, so I'm going to factor a 2 out since it ends in an even number. I got 2 times 49. All right. Now I got an odd number, so I can't factor a 2 out of 49, but 49 is on my little cheat sheet of 7 times 7. So I can now simplify the denominator as 7 radical 2. Everybody good so far? Okay. Now, some of you are going to stop there, but unfortunately, if you remember in the early discussions, is that we cannot have a radical in the denominator or the lower half of the fraction. So what do? If you go back and look at the example on the front side, I multiply that whole thing by radical 2 over radical 2. Why radical 2? Because remember my 7x example? Anything under the radical times itself in a square root practicality equals, comes out from under the radical as itself. All right, so we watching? All right, so radical 2 times radical 2 is the same as 2 squared on the radical. So that comes out from under the radical as 2. And 2 times 7 is 14. Now, this is crazy, but that's the way it is. All right. So then I just multiply this. I multiply what's in the radical times what's in the radical. So my final answer, drum roll please, is a cubed b, looks like, and then we got 2, here's the 2 times that radical under the b. So now I got 2b. And that's the ultimate answer you want to work to. Ba-dum-bum. Questions?
No.
Nope.
So, moral of the story. I've done 1 3 5. If you give me about 10 minutes after we wrap up class, I'll load this problem set on Blackboard if you want to download it. Which I would suggest if you've got a printer at home, go ahead and print it out because you've got those nice properties on the top third or top half of the problem set that you want to rely on as a reference. Okay. You only got 3 problems to do. A couple things. Be careful of whatever route you're taking. All right. Be careful if you end up in the process with a radical in the denominator. You now know how to get rid of it. This is that complex conjugate stuff that was on, I want to say back in chapter 4, where we use complex conjugates to eliminate radicals in the denominator. Okay. What else can I tell you? You only got 3 problems. Spend a little bit of time on it. If you run into a snag, either go to Patrick JMT, his site was down earlier, or Khan Academy, and just type in the search bar there, operations with radical expressions, or simplifying radical expressions, all right? And there's some videos there that you can use also as a refresher and a different kind of take on how to approach them. All right? Questions?
Can you show us which one that you did?
I'm sorry?
Can you show us what 3 problems that you did, like number 6 and what other 2?
You're gonna do 2, 4, and 6. Okay.
Can you show us 2 and 4?
Oh, so you can cut them down. Sure. Let me scroll up.
Yeah.
Let me clean up my mess. Okay. Let me see if I can get this out of this is in the way for me anyway. All right. Where's my pen's gone wacky? All right. All right, so there's 2 and 4 if you want to copy them down. All right. 4 should be a real quick one. As you can see, a perfect square there in the bottom, in the top. Again, if you want to kind of simplify things to kind of, again, break it into smaller chunks, you know, rewrite it as 36 under the radical over 125 under the radical. You might see something that you don't see with it written as it's written right now, okay? You know 36 is a perfect square, right? You know 125 can be divided by 25, right? You know this one, I'm gonna start factoring 2s because that's a nice even number, and I know I'm gonna, and then you wanna look at a to the 9th as, well, let's look, I think I already told you, I'm gonna look at b to the 20th as b to the 4th times 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 b to the 4th, all right? So the b's should come out from under the radical completely. You shouldn't have any b's under the radical number 2. All right, we're coming up near quitting time. Other questions I can answer? Give me about 20 minutes and I'll load this up on, don't worry about putting it in Dropbox because there's only 3 problems. And it is a little, it's like, you know, the complexity of simplifying things under the radicals definitely ramped up with this problem set. So just kind of work a little slower, a little more methodical, right? And use Khan or Patrick JMT if you want to hear another person's explanation. Any questions, comments before we depart the fix? Everybody's quiet today. Any questions?
No, sir.
Okay, you guys are good to go, and I will see you Wednesday at 1 o'clock.
Mr. Gaffney.
Yes, sir.
Thank you, Mr. Gaffney.
All right, we'll see you.
See ya.
Somebody had a question? Any questions? Mr. Garcia, while you're still on, you may want to go back and look at that quiz. Those first 6, you lost some valuable points by not following instructions. And if you've got any questions on that or want to talk to me about it, I'll be on office hours at 2 o'clock. All right. Okay, hearing no questions, we are good to go.